All right, today's lesson, chapter 9.3, polar and rectangular forms of equations. So what we are looking at, over here, we have point P. In rectangular coordinates, it would be x comma y. In polar coordinates, it would be r comma theta. So whereas rectangular, we go left, right, then up, down. We kind of take the scenic route. Polar coordinates, we're still standing here. We just turn and face the direction we want to go and go straight to it. R theta. All right, now how are they related? You should already know this. We've been doing it pretty much all year. X is r cosine theta. If you forgot, real quickly, we do SOHCAHTOA. Okay, relative to our angle theta, x is adjacent, r is the hypotenuse. Adjacent hypotenuse tells us to do cosine. So you've got cosine theta equals x over r. Multiply both sides by r. So we get x equals r cosine theta, etc. We do the same thing for our sine and y to get y equals r sine theta. But in all honesty, you should have those two things memorized already. On our unit circle, you tend to think of x as cosine theta. You sometimes forget the r, but on the unit circle, r is 1. So x is r cosine theta, y is r sine theta. So understand what it is that we are looking at right there. So number 1, find the rectangular coordinates for each point given the polar coordinates. So your polar coordinates are r and theta. They want it in terms of x and y. Simple enough. So x would be r cosine theta. In this case, my r is 4. And the theta is pi over 6. Now it requires your knowledge of your unit circle. What is the cosine of pi over 6? Square root of 3 over 2. Do the arithmetic. X is 2 square roots of 3. Do the same idea for y. Y is r sine theta. Again, it's still 4 sine of pi over 6. So what is the sine of pi over 6? And now that you know your x and y, again, it wants the rectangular coordinates. So x is 2 square roots of 3, y is simply 2 as your ordered pair, x comma y. B, let's find the rectangular coordinates for point Q, which is -2, 135 degrees. Nothing changes. It's still the same process. X is r cosine theta. So x would be -2 times the cosine of 135 degrees. So what is the cosine of 135 degrees? Okay, negative square root of 2 over 2. Do the arithmetic. The negatives and the 2's cancel out, so all we're left with is just square root of 2. Now let's find y. So what is the sine of 135 degrees? Positive square root of 2 over 2. Again, the 2's here cancel. So it's just going to leave us with negative square root of 2. And again, once you have your x and your y, write your answer. All right, C. Point V. 3 comma negative 120 degrees. Still, nothing is changing. Might make you pause a little bit longer on your unit circle to make sure you're in the right place, but it's still the same formula. X is r cosine theta, so it's going to be 3 cosine of negative 120 degrees. Well, where is negative 120 degrees? Remember, that's coterminal. Just add, subtract circles. Negative 120 degrees, if you add a 360 to it, it's the same thing as 240 degrees. So really, what's the cosine of 240? And we get negative 1/2. So, doing the arithmetic, x is negative 3/2. Y is r sine theta. So it's going to be 3 times the sine of negative 120 degrees. And again, negative 120 degrees is the same thing as positive 240 degrees. Just adding circles. So what is the sine of negative 120 degrees? Negative square root of 3 over 2. So we get a y value of negative 3 square root of 3 all over 2. So our answer at this point is that. All right, that was page 1. Page 2. Let's go the other direction. To write a pair of rectangular coordinates in polar form. Now what we're looking for is the distance r and the angle theta. But how do we find those? Well, if you are looking at your triangle right here, if you know x and y, got too much scribble here. If you know x and y, how would we find r? Pythagorean theorem. X squared plus y squared equals r squared. What else do you know that x squared plus y squared equals r squared? The equation of a circle, centered at the origin. So, our x squared plus y squared equals r squared is the equation of the circle. It is also your Pythagorean theorem. Now, what about theta? Well, I'm looking for theta. Again, I know y and I know x. Well, how are those three things related? Okay? So, Katoa. Y is opposite, x is adjacent. That would tell you to use tangent. Okay, but we're looking for the angle. So tangent of theta equals y over x, which means theta is the tangent inverse of y over x. So again, those are the formulas you need to know. X squared plus y squared equals r squared, and that theta is the tangent inverse of y over x. All right, so number 2. Find two pairs of polar coordinates for each point with the given rectangular coordinates. Find two pairs of polar coordinates for each point with the given rectangular coordinates. Alright, so we have the rectangular coordinates. X is 1, y is negative square root of 3. How do we find r? Simply, r squared is x squared plus y squared. So r squared will equal 1 squared plus a negative square root of 3 squared. Which is r squared is 4, which means r is 2. Now, what about theta? You might need a little bit of help with this. Okay, theta will be the tangent inverse of y over x. So it's the tangent inverse of negative square root of 3 over 1. So then the question is, where does tangent equal negative square root of 3? Well, in the unit circle, it actually happens at a couple of different places. The question is, which one's the right one? So we might need to draw a quick triangle. Just make sure we know where we are. All right. If x is 1, y is negative square root of 3. So that tells us to go 1 to the right, down a negative square root of 3. So it tells us we are in quadrant 4. Now, hopefully also, just simply by looking at this triangle, you should recognize what kind of triangle it is, and know then that the radius is 2, which actually confirms with what we found already. But it should also help you identify this angle. So what we have here is a 30, 60, 90 triangle. So we're looking at 60-degree angle in quadrant 4. So that would be 5 pi over 3. Now from our last lesson, we talked about that there were actually 4 pairs of polar coordinates for each point. So why they're only asking for 2 kind of confuses me. Because there's actually 4 answers, 4 possible answers. So with that in mind, then if you're checking your answers, we might not all be doing the same ones. But the most direct is simply to do the 2 comma 5 pi over 3. So that one's kind of a given. Everybody should do that. Now the question is, we got 3 more choices, they just want 1 of them. Let's see. I guess since we already know this is just 60 degrees in their quadrant 4, let's just do our other one. We're still going to walk forward, so let's just go that opposite direction, which would be simply negative pi over 3. So I would do those, but just to be clear, we could have just as easily have gone clockwise here and walked backwards, so our radius would have been negative 2, or we could have gone, what I said there, counterclockwise, or we could have gone clockwise this direction and also walked backwards. So there's still a couple more answers that could be used. Alright, next question. T, with the ordered pair negative 3, 6. 6. Here's your R, here's your theta. Alright, now this is not a triangle we know. So you got to do all the math, and you already know the answers are not going to turn out to be nice and pretty because, again, it's not a triangle that we know to be nice, neat answers. Process, though, does not change. So, to find R squared equals x squared plus y squared. X is -3, y is 6, and whereas I typically would prefer you simplify the radical, if what we're doing with this, they're doing decimals. So reach for your calculator, punch out the square root of 45, and looks like we got 6.71. Kind of the same idea for theta. We know it's going to be tangent inverse y over x. Now, here's where you got to be careful because your calculator is going to lie to you. So, reach for the calculator and do the tangent inverse of -2. Now, my calculator, when I did this, was in degree mode. So, it doesn't matter what mode you're in. So, you have to know which mode you're in if you're going to get different answers. Okay. In degree mode, calculator told me -63.43 degrees. So what did the calculator tell me? It told me the quadrant 4 angle. Okay. Remember when we were talking about sine and tangent? Sine and tangent go back and forth this way. Positive in quadrant 1 and the negatives in quadrant 4. Whereas cosine goes quadrants 1 and 2. So, point being, the calculator just gave me -63.43 degrees, which means, in other words, the calculator just told me this angle of -63.43 degrees. Not where I want. I'm not looking for this angle in quadrant 4. I'm looking for this angle over here in quadrant 2. Well, hopefully you recognize that these would be vertical angles. It is 180 degrees away. So what I need to do is, from this angle, start with this -63.43, but I need to add 180, because that right there is 180 degrees. So a real angle is going to be, that way would be easier math. I'm going to say the -63.43 degrees, but plus 180 degrees. I'm going to do that. Then we actually get 116.57 degrees, which would be a quadrant 2 angle. Makes sense now. So, writing my answers, the most direct answer would be radius of 6.71 at 116.57 degrees. Now again, that is simply one of the 4 polar coordinates. Following my notes on what students in the past have done, they prefer to continue to walk forward and just go in the opposite direction. In other words, take the 116.57 degrees and subtract 360 degrees. Go the other way. So if we subtract 360 from it, so what I'm really doing now is going this direction. And when we do that, we get negative 243.43 degrees. So those are two possible answers. There are actually four. All right, flipping the page. Long lesson here today. All right, number 3. Write the rectangular equation in polar form. All right. Hopefully this is quick and easy, but what you basically got to know, go back and forth, you got to know x is r cosine theta and y is r sine theta. You have to know those things. You also have to know x squared plus y squared equals r squared, and tangent theta equals y over x. So, putting all those different things together, write the rectangular equation. Means right now, write it in polar form. Right now we have x's and y's. We don't want x's or y's anymore. We want r's and thetas. Okay, in this case we're not actually going to get thetas, because plain and simply x squared plus y squared is r squared. So since x squared plus y squared equals r squared, I end up with r squared equals 9. Or simply r equals 3. So there is no theta, but it is now polar form. Next one, x equals 4. So, again, coming back to this, x is r cosine theta. This is what I'm looking at. So, in place of x, we're going to say r cosine theta equals 4. Now that itself would be in terms of r and theta. What the book does, though, they prefer to have it in terms of r equals. So what they did is they divided everything by cosine theta. That cancels. So now you've got r equals, and cosine theta on bottom is the same thing as secant theta on top. So that is the answer they have for that one. Next one, C. X minus 4, quantity squared. Plus the y squared equals 16. Everywhere I have an x, r cosine theta. Minus 4, mean squared. Plus, everywhere I have a y, I need parentheses, r sine theta, because that whole thing is being squared, and it's all going to equal 16. But now, right here, I've got a binomial being squared. Binomial squared will expand as a perfect square trinomial. So, we get r squared cosine squared theta minus twice their product, which would be 8 r cosine theta, plus the last term squared, 16. Plus, now, this one over here, though, it's just a monomial being squared. There's no pluses or minuses, so just everything gets squared. So we get r squared sine squared theta. And it all still equals 16. Now, hopefully you recognize some things. I'm going to leave these two right there where they are, and the rest of the stuff I'm going to move to the other side of the equal sign. So we're going to subtract the 16. Just going to make those go away. But we're also going to add 8r cosine theta. So add 8r cosine theta. If we do this, that will leave me with r squared cosine squared theta plus r squared sine squared theta equals 8 r cosine theta. Okay, left side. Anybody recognize anything we could do there? Factor out in r squared. You factor out in r squared, DCF, we are left with cosine squared theta plus sine squared theta equals 8r cosine theta. And what is cosine squared theta plus sine squared theta? Your main Pythagorean identity. That just becomes 1. R squared times 1 is simply r squared. So r squared equals 8r cosine theta. And then, going one step further here, divide both sides by r. When we divide both sides by r, now we end up with r equals 8 cosine theta. And that is our answer. So, a little bit of algebra, some factoring, knowing your trig identities. Several different things involved there. Alright, now the next one. Y equals x squared. R sine theta equals R cosine theta, and parentheses, the whole thing gets squared. R sine theta equals R squared cosine squared theta. Now, these aren't matching up quite so nice, but we can go ahead and just simply divide both sides by r. So, sine theta equals r cosine squared theta, and generally want to solve for r. Let's just divide both sides by cosine squared theta. Now, you may not need this, but I'm going to go ahead and separate just to make sure I don't lose anybody. I still have a sine theta on top, but on bottom we have a cosine squared theta, which would be a cosine theta and another cosine theta. So looking at it like that, we can see then that r is tangent theta, secant theta. All right, and one last page. Now we're going the other direction. We are given the polar equation. We want to change it to rectangular form. So, theta equals pi over 6. going to do? Take the tangent of both sides. So tangent of theta equals the tangent of pi over 6. What is tangent theta? Tangent theta is y over x. And everything we're doing is coming back to these ideas. Tangent theta is y over x. What's the tangent of pi over 6? Well, you know that from your unit circle. Tangent of pi over 6 would be the square root of 3 over 3. And now, if you just simply multiply both sides by x, we get y equals square root of 3 over 3 times x. It is now in rectangular form. We now have it in terms of x to y. And that would be the equation of what? A line, which we also did somewhere, not sure where. Oh, that was on yesterday's lesson. Never mind. Previous lesson where this theta equals pi over 6 was a line. So, sorry, go back to chapter 9.1 for that. All right, B. R equals 7. All right, now, be careful with this one. We could look at this two different ways. One's right, one's wrong. If you were to multiply both sides by r, that would make this side become r squared, which is good and helpful. But it would leave still a single r over there, which is not so helpful. So, whereas that seems like a reasonable, logical thing to do, that's not going to help us in this case. Instead, I don't want to multiply both sides by r. I want to square both sides. Now, that still gets me r squared on the left, which is good. But now I don't get that r on the right, which is also good. Now again, what is r squared? In terms of rectangular coordinates, r squared would be x squared plus y squared. So we end up with x squared plus y squared equals 49, which would be the equation of a circle. Centered at the origin with a radius of 7. All right. Next one. R equals -5 sine theta. Now this one, I'm going to do just the opposite of what I just told you. This time, I do want to multiply both sides by simply r. Because I don't want this to just be sine theta, I want it to be r sine theta. So I do need the r. So I multiply this side by r, multiply this side by r. Now we have r squared on the left, but I've got -5 r sine theta on the right. Left side, and for the right side, r sine theta is just simply y. Now, I don't know why you can't leave it just like that. I think you probably can, but the textbook people, they went ahead and just moved the -5y to the other side. So they wrote x squared plus y squared plus 5y equals 0. It doesn't really matter. Just so that when you're checking your answers, they just moved it one step further. All right, and the last problem in this list Alright, R equals. This one looks a little more interesting. Now, hopefully you immediately recognize a particular need looking at your denominators, and that is they need R's. I don't want just cosine theta, I want R cosine theta. I don't want just sine theta, I want R sine theta. But notice we do have an R already over there. So, for me, I would just put this R over 1 and cross multiply. So when we cross multiply, I get 6 equals 2R cosine theta minus 3R sine theta. Real quickly then becomes 6 equals 2x minus 3y. And they left it in that form. So again, sometimes they make it equal to 0, sometimes they don't. Kind of hard to tell. But that is lesson 9.3. That was a lot of stuff in this one. Going back and forth between polar and rectangular coordinates, going both directions.